Welcome to BTEC Revision. In today's lesson, we're looking at reluctance and magnetic screening. By the end, we should be able to calculate reluctance, magnetomotive force, and magnetic flux, and describe magnetic screening. What is reluctance? Reluctance, S for short, is the magnetic resistance to the presence of a magnetic field, and can be calculated via this equation. Reluctance equals magnetomotive force divided by magnetic flux. The short form is S equals Fm divided by phi. If you remember in our previous lesson, magnetomotive force is equal to the number of coils times the current. Therefore, the unit is going to be ampere turns. So for Fm, unit is ampere turns. And if you remember magnetic flux, which is equal to BA, that's magnetic flux density times area, and B is measured in Teslas, A is measured in meters squared. So magnetic flux is Tesla meters squared. And it also has a special unit called Webers. So that's WB for short. Therefore, we can write Webers for magnetic flux. Therefore, the unit for reluctance is AT per Webers. And it also has a special unit called the inverse Henrys. This is equal to H capital to the power of -1, where H stands for Henry. Now, let's look at this example. A magnetic circuit experiences a magnetomotive force of 150 ampere turns and a magnetic flux of 0.002 Webers. Calculate the reluctance. We'll start by writing down our equation. S equals Fm divided by phi, and we can plug in our values. That's 150 divided by 0.002, and that's equal to 75,000 Henry to the power of -1. There is also another equation we can use to calculate reluctance, which is equal to length divided by permeability of free space times relative permeability times the area. And the short form is S equals L divided by mu naught mu R A. If we remember the equation for mu R, which is equal to mu divided by mu naught. Remembering our equation for mu R in the previous lesson, so relative permeability is equal to mu divided by mu naught. And the units are H per meter, Henrys per meter, divided by H per M. So that cancels out to give mu R no unit. Mu naught is H divided by a meter. And looking at the units here, so we've got meter for length and meter squared for area. So compiling all these, we get meters divided by H meters squared divided by meter. So we can cancel out the bottom meters, one from the bottom, one from the power, and then we can cancel out the top meter with the final meter. So all the meters cancel out. Therefore, the units for reluctance is the same as before, 1 over H, where H stands for Henry. What is magnetic screening? Sensitive electronic components may need to be shielded from unwanted magnetic fields. We are able to create shields using ferromagnetic materials that have low resistance. The magnetic field would then pass along the path of the ferromagnetic material. As you can see in this picture on the right, the field lines are passing along that material, and the components would therefore be protected. So anything inside is protected from this magnetic field. We can start by writing down our equation. S equals L divided by mu naught mu R A. We know the length is 0.1. Mu naught is the permeability of free space, which is 4 pi times 10 to the power -7. And mu R is 2000. And the area is 2. And this gives us a value of 19.9 per Henry. Now pause the video here and attempt this exam question. A magnetic circuit consists of a circular iron core with a length of 0.1 meters, a relative permeability of 2000, a magnetomotive force of 150 AT, and within a magnetic flux of 2000 Webers. Calculate the diameter of the iron core. We can start by writing down our equations. S equals L over mu naught mu R A, and S equals Fm over phi. Now, we can think about what we need to work out. So it's saying that we need to work out the diameter, and it is of the iron core, which is circular. So the diameter of a circular object, we would know is, we can use the area of a circle, which is pi r squared. So if we work out the radius first, then we can times by 2 work out the diameter. So that means we need to work out the area. Now let's see what we have. We've got a length of 0.1 meters. We have a relative permeability, 2000, so we have that. We have mu naught, which is a constant. Area is the question. We have Fm, which is 150, and we have magnetic flux. So if you look here, we can equate these two equations and rearrange for A. So L over mu naught mu RA equals Fm over phi. So rearranging for A, making A the subject. Therefore, we would get A equals, so that goes over here, and that goes down over here. We times this over to the top. So we have phi L, Fm gone to the bottom, and then mu naught and mu R. Now we can plug in our values. So phi, and the flux is 2000 times a length, 0.1, divided by Fm, so magnetomotive force is 150, and the constant is 4 pi times 10 to the power minus 7, and mu R, relative permeability, is 2000. And this gives us a value of 530 meters squared. Now, we know that the area of a circle is pi r squared, and we know the area is 530. We rearrange this for radius. So radius equals area divided by pi, and then square root. So we can plug in the values. The square root of area over pi. So divide that with pi. Gives us 168.87. Square root our answer. And the radius is 12.99 meters. We times that by 2. Diameter equals 2 times the radius, and that gives us a value of 26.0 meters. And that's the end of the lesson. If you'd like to boost your grades, visit us at beta@revision.com. See you next lesson.